Hey everybody, welcome back to the Pomerium live stream. I'm your host Nick Taylor, and today I'm hanging out with my buddy Abby. Abby, how you doing today?
Hey Nick, I'm good. How are you?
I'm
Did I
pretty
trouble
good.
you? Is it too early?
No, it's definitely not early. I've been up for a couple hours, but yeah, no, I'm doing good. I didn't sleep as well last night. Not because uh I don't know. We have like a live stream release later today, and I'm just honestly super excited about it. So I just was thinking about it last night, so I couldn't fall asleep. But aside from that, I'm doing well. I still
Good,
got
good,
some sleep. So
good,
what
good,
about
good. As
yourself?
long as I didn't trouble your sleep, that's good. And thanks for being flexible to do it a bit early as well. And yeah,
Oh yeah,
looking
cool.
forward to our chat.
Yeah. So for folks who don't know you, Abby, mind saying I guess a bit like what you're up to these days, where you're at, and if you want to as well, you can kind of. I think you'll get into it, but like kind of how did you get into tech kind of stuff too?
Yeah, for sure. For all the viewers, I'm Abhi, also known as Diabe on the internet. And I lead our developer advocacy team at DigitalOcean. Been here for like over 3 years. I mean, almost 3 years now. So that's as time really flies by.
Yeah.
Um, yeah, prior to that, I was at a Kubernetes startup,
Okay.
one of which got acquired by Akamai, and yeah, I've held multiple engineering roles. Started as a simulation software engineer at Lockheed Martin, programming cockpit display systems, embedded systems for full flight simulators. So that was pretty cool. And then moved into automated robots that are deployed across multiple car manufacturers in Europe. Like we have our robots are running in Tesla factory, Mercedes, and a couple of others as well. So that was
Okay.
fun. And then I was the lead engineer at a medical startup working on IoT, but mainly helping patients with sleep apnea and how do you detect that. So it
Okay.
was more of IoT. And then while I was doing all this, I used to share my work with the community. And I'm based in the Netherlands, by the way. Originally from the south of India, but moved here about 15 years ago and kind of never left the country. And yeah, so when I used to share the work with the community here. And then one of the founders of the startup reached out saying, "Hey, do you want to join as our first developer advocate in the company? We
Okay.
need someone to with technical background and try to showcase what we're building to the community and to the world." And I was like, wow, I can get paid for this. that's
Yeah. Totally.
that's awesome. So that was yeah, that's how I got into like advocacy. And then I joined Dio
Okay.
as one of the Kubernetes advocates, and eventually like now I'm leading the team. So so it's been a quite a ride. And I to be honest, I really enjoy it. And it's
That's
like
cool.
a amazing space to be where you get to explore different products and like try out different things.
Yeah.
But as dev advocates, there are two things that the team and I are focused on is to inspire people through talks or webinars, these demos, and then equip them with the right set of tools and digital assets, and providing them with like content or tutorials, as building SDKs and CLIs.
Okay.
So enabling, inspiring, and enabling is what we are primarily focused on at DO.
Oh no, that's cool. That's cool. No, that's awesome. Yeah, I'm not saying this because you're on the live stream, but I typically use DigitalOcean a lot to just do my demos. I find it pretty easy to set up with a droplet, like for the stuff I'm doing with Pomerium. And I know that's not the only thing you have at DigitalOcean, obviously, but I find it's kind of like a pretty low stakes way to just kind of get up a demo pretty quickly for me, at least. So
No, fully agree. I mean that, as you mentioned, that's not the we've come a long way, and that's also part of our job is to showcase to the world how far we've come, and not just droplets. And we are known for our droplets, obviously, and also our amazing tutorials. But there is so much more to how we've up-leveled ourselves in targeting our digital native enterprises
Yeah.
and moving up market. So we've come a long way. Particularly, also there are some really cool announcements going to happen next week um,
Nice.
in the AI front, and yeah, so we're pretty excited, and we're tackling it from different angle as well, like right from a bare metal infra standpoint,
Hmm.
way up to building agents. So that there's like going to be a complete stack, and there's going to be a slice of pizza for each and every segment of people across the organization, and that's how our product teams are thinking through. So
Okay,
we're
cool.
pretty stoked about it, and yeah.
Yeah, so even the people who like pineapple on their pizza, there'll be something for you too.
Oh, they are banned. They are banned. That's definitely not happening.
Yeah,
At
that's it.
least, at least.
That's it. The stream's canceled. We talked about pineapple on pizza.
Yeah,
Sorry,
that's it.
Abby.
I'm joking.
Awesome. So we're gonna you're gonna give us a demo today. I saw a quick preview. It looks super cool. So this is about we're talking about AI agents, but leveraging event-driven architecture. And for folks who might not be familiar with event-driven architecture, like we don't have to go super deep right now, but like what's kind of like the TLDR? If somebody's like, I just want to know what is EDA.
Yeah. So, I mean, I have an entire story for it, but the
Yeah, yeah,
TLDR is im- i- imagine an event is like an immutable task. So something um, how do I put it in a way? So let's take a step back, right? Let's come to
yeah,
event
yeah,
driven architecture, but I want to first set some stage on why even event driven architecture came into the existence, and what's the use of
okay,
that, right? Like we kind of like started with the whole monolithic applications when everything was like tightly coupled, and you had multiple services within a single monolith, and they were like tightly coupled, and if you had to scale one, and you had to
yeah,
scale all the other services, and that led to microservice architecture when you kind of decoupled these monoliths into several other
yeah,
services. And then what happened was, when these inter-service communication happened, there was we hit a bottleneck, and the bottleneck was every other service was dependent on the following other service. So imagine you have a pizza delivering system. Let's talk about pizzas, right?
yeah, yeah.
Like
We're
let's
back
say
on pizza.
someone orders a pizza,
Yeah,
and there's a service to process this order, and then let's say it's dependent on someone to it sends the request to the chef, and the chef makes the pizza, and it's waiting on the chef to finish the pizza so that the service can communicate to the user that the pizza is ready or something like that.
yeah,
So you see this chaining happening, but this is happening in sequence. So someone has to send this request, and it's waiting on a response, and then once the response is back, it notifies this. So there is like a chaining happening, a request response mechanism. This is fine if your systems are um, uh, like small and not like really large scale systems with a lot of
yeah,
requests coming in, right? But this is kind of tricky when there are like hundreds and thousands of people interacting with your service, and then trying to there'll be delays, and we don't want that. This led to something called the event driven architecture, like
mhm,
microservice architectures, but you started applying more event driven patterns, meaning all of a sudden these services could talk to one another completely asynchronously and decoupled. So none of them were like even aware that the other services existed, but they were
yeah,
communicating through some sort of a message queue. So imagine a message queue and a little.
yeah. Oh, you broke up for a second here. I think you'll be back in a sec. If you can hear me, Abby, you're
Am I
oh, there
back?
you're back.
So
You're back. Yeah, yeah.
I don't
That's
know
all
where,
good. You
where
you
you
froze
lost
for
me.
a second.
So, I
Uh,
mean,
yeah, you were talking about the
car
messaging queue.
yeah, so basically think of messaging queue like a car manufacturing plant when there is someone who's actually, doing the paint job, and there's someone who's actually fixing the tires, and someone who's fixing the tires unaware, like, is not bothered about someone's doing the paint job or not. He just goes through an entire queue, and whenever their job comes in, people are busy picking that task up, fixing it, and then putting it back into the line, and then the next car comes and the next car comes. So each
Hmm.
one is taking the so it's similarly, you create like a message bus. So this is how the MQTTs of the world, the message brokers of the world, the Kafkas of the world came into existence, where you could just
Okay.
feed this status into a message queue, and then there are like producers who are producing these statuses. There are like consumers who are actually receiving these updates and processing them, but each of them are unaware that each of them exist. So it's completely asynchronous and loosely coupled, right?
Yeah.
And this led to how you could build these large scale distributed systems, in essence. And when I was thinking, like, I'm not an AI expert or an ML expert. I come from an infrastructure background. I worked with message queues a bit, like
Yeah.
MQTTs and RabbitMQs. Definitely not Kafka. Um, but when I was thinking about what would be an interesting area to tackle, like from I wanted to experiment, and this question kept popping in my head, like, why can't, like, how would these agents, AI agents, communicate
Hmm.
with one another at scale, and why can't we apply this EDA pattern to them?
Okay.
Because in essence, if you see, these agents are anyway these microservices or micro apps, which we'll go through the whole. I have a couple of slides to bore your audience anyway, but that's just to set some context before we go into like building these apps. So
Yeah.
can I
Okay.
share my
Excellent.
screen?
Yeah. Yeah. Let's go for it. All
I don't know,
right.
the light turns
I'll
off,
bring
but
us over here, and yeah, just pop your screen in.
I don't know why my
And
lights
that
are
is synced.
flashing, but I'll probably turn it off.
There we go. You're in.
Yeah, I don't know why my light's flashing in, but let me turn that off as well. Okay, cool. Right. So this is the question that I was trying to answer. Basically, how would these agents at scale communicate with one another, and what would that
Hmm.
look like? Right. We, I mean, AI has come a long way, right? Like the initial talk of AI started in like 1950s, and later in your mid 2010s, you had the AlexNets of the world and the GANs of the world and the whole convolutional neural nets popping up. And then you know what happened in like 2017, 2018 when the transformer architecture was proposed,
Yeah.
and then that led to the birth of the GPT of the world. And end of 2022 completely changed the way we approach interacting with these systems,
Yeah.
with the launch of chat gpt. But now we are entering into this new era where it's not just like you're asking something and it's going to respond to you, but you're moving into an era where these systems are going to take high agency, and they're going to operate, they're going to plan the tasks, they're going to execute their tasks, and they're going to communicate and collaborate with one another,
Yeah.
um, and perform, right? That we're entering into this era. Are we there yet? I don't think so, but will we get there? For sure we will eventually get there. Maybe there are already some areas where it's already turning into that agentic flow. And the one such example is, you see the cursors or the windsurfs of the world, where you set some
Yeah.
give it a high level task, and it goes and fixes and builds the code for you, so it does something on your behalf.
Hmm.
um, and I think we should just embrace it rather than completely saying, oh no, this and you could probably embrace it from your own angle, right? Like if you're a security person, how would you apply security practices to building an agentic workflow? And
Yeah.
I'm a infra person, so I'm like, how can I apply, what would the infra look like for agentic communication? And this is a problem that I want to tackle. And I think if people start thinking about it from their relevant expertise,
Yeah.
eventually we'll come to we'll streamline the whole process, and I think we'll have like solid frameworks that allows us to build these end-to-end agents at scale. But that's something that I also want your audience as well, people who are listening in, just to know that we just embrace it and just apply it from your angle and
Hmm.
see what happens, right? But
Yeah.
there are all these definitions are like, I think the word agent is like misused a lot in the industry.
Yeah.
But I kind of liked what AWS put out. So basically, AWS was like, I'm just paraphrasing it. It's a software program that uh, has a certain context and it's operating in a certain environment. It
Hmm.
performs, it reads the data, analyzes the data, and here's the crucial part, that it performs self determined tasks to achieve a predetermined goal. So
Hmm.
you set high level goals, or another agent or another system sets these high level goals, and these agents should be smart enough to figure out a way to get there.
Yeah.
And these agents are composed of multiple facets. You can think about persona as a job description. Like, what does your skill set look like? What are your strengths? What is the
Hmm.
context? Like, what is your um, you
You broke up for a sec. I'll give it a second. Um, yeah. It's all good. Yeah. So you were saying, just talking about, what's the job description? What are
yeah,
what are your skills?
yeah. So basically, perception is like, I don't know what happened to the internet. It just keeps. But anyway, perception is like the inputs into your system. Like, is it an LLM input, or do you need like a user input? And it's
Hmm.
basically like your sensory organs into your agent. And memory is can be classified into two. One is like a short-term memory that you need for to building the context,
Hmm.
and then you have these long-term memories that it can actually go and fetch and understand the historical uh, context, or if it needs to store this information for something that it needs to process later. So you have these long-term memories built in. Tools is nothing but what kind of functions do you want to invoke
Yeah.
based on the tasks at hand, and is that involve another API call, or it can be a call to an MCP server. And then eventually you end up building, like set doing an action, and you got to do this repeatedly. So this is how on an AI agent on a very high level should be composed of. Um, I mean, again, this is my take on it. There
Yeah.
can
Yeah.
be some different nuances, but this is just setting the stage here.
Yeah. For sure. No, that's a great explainer.
Yeah, I mean, if you look at it, when I was explaining it, it's like these are these micro apps, right?
Hmm.
Um, they are isolated, they are decoupled, and they have a certain specific function, kind of like microservices, what we touched about. But how do you is intelligence truly only needed for it? No, you need security, you need observability, you need governance, you need them to be deployed on a solid infrastructure,
Yeah.
right? Operating system here might be a bloated term, but that's also to to get the audience think about it. But you know where I'm getting. I just want to understand what that plumbing would look like under the scenes,
Yeah.
what is going to hold everything together. And that's what we are. This is something we already touched about, like, yeah, with the evolution of these event driven architectures. How can we apply that to AI agents and see what it is, right?
Hmm.
Um yeah, enough of me talking. And if you don't
Yeah.
show things, if you don't like, so what we're going to see is, I think might be interesting to the audience as well, is I built this Uber like ride share application,
Hmm.
um, where you have users requesting for a ride, and then you have these taxis going and picking up these users, but under the hood, you'll see the architecture where there's like an orchestrator agent, which is responsible for assigning these rides. There is a billing agent that is actually processing the billing, the invoice of all these rides, and everything is happening asynchronously, completely in asynchronous fashion.
Hmm.
If the demos don't work, we will play this video, but this is just to show you. Does it play? Let me play that. It's playing. Is it playing?
I see. I see the. I don't see things moving, but oh yeah, now it's moving.
Yeah,
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 yeah.
right. Okay. So I just deployed a couple of these users in Taxi. So this is what we're going to do live after this, but it's just to show you, setting you what you can expect out of this app, basically.
Okay.
So you see the ones in greens are the available taxis. The ones in red are the ones that are busy. The users are popping up on the top left. If you see, there's a user popping up who's requested for it. These are actual routes that are being calculated, which I'll show you. These are not like just dropping some random cars on the map.
Okay. Okay.
Um,
Yeah. Yeah.
and everything is like completely containerized, like microservices. So this is what we're gonna see. Um, right. Any questions so far before I move to the other screen?
I'm just hoping my driver doesn't cancel my ride.
So let's go into the architecture, and this is what I think might be interesting for folks. And this also explains about the whole, which is why when you started, and I was like, I wanted to explain it, but this with the visual representation, event driven makes much more sense.
Yeah.
I'm audible, right? All good?
Oh yeah. 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 It's all good.
Okay, cool. Right. So that was the app, and this is what's happening under the hood. Everything. So all these purple um, boxes that you see are Python services, completely
Okay.
containerized. This is going to be your user generator. So it's basically a user like randomly picks up a spot and then sends the coordinates, like the user's name, the coordinates, where they are, whether they need a ride or not, and it's like the status is updated as a user topic. So topic
Okay.
is, I mean, these are like Kafka terms. Okay, you can assume topic as think about Kafka as a newspaper. You have a newspaper. The Kafka broker as a newspaper. So you have a newspaper, and
Okay.
you have the main headlines, you have the politics, you have sports news, and so all these sports news headlines, politics, and these are topics. So the user, as a user, let's say you're not going to, or I've never read like the entire newspaper. So basically, I'm more interested in like what's the sports news or what's like the I don't
Yeah.
know, politics. So you kind of like segment it based on the topics, right? Like in this case, there is a user topic which is responsible for all the information about a user,
Yeah.
and the same way there is a taxi generator, which is basically a producer in Kafka terms. It's sending out the taxi location, whether the taxi is in a particular coordinate, where is it? Is it occupied? Is there already a user in there? Who's the driver details, etc. So all this is sent into the message queue
Okay.
here.
Yeah. That makes
And
sense.
then there, yeah. And then if you look at it, this is an orchestrator agent, right? This orchestrator agent is not worried about who is sending the, or doesn't even know that there is a user generator or a taxi generator. You can replace this with anything else that just makes sure that it satisfies this user schema. This orchestrator, so these are completely decoupled. So this orchestrator is basically consuming these topics and saying, okay, here's a user that's coming in. Here are the neighboring taxis. So it does all the calculation, and
Okay.
it because it knows where the users are. It has a information of where the taxis are, what are available or not, and then it makes the assignment. It says, hey, user A, you're assigned to taxi B, and taxi B, go pick up user A. And then that information is sent as a write topic. It's a different topic. And there's a reason
Okay.
for it, because you don't want to keep updating the same topic with overwritten data, because then it gets a lot more confusing. So you have a write topic, because the billing
Okay.
agent, for example, need not understand where about the username or whatever. It just needs to know how long the taxi moved from point A to point B, what was the current location,
Yeah.
what was the current taxi date, right? So you send it in a different topic and say this is a right topic which has information about who the user is, what the taxi is, where is the location, where do you need to go pick it up, right?
Yeah.
The front end where you saw the map is like a fast WebSocket server that's running here, fast API. It's
Okay.
basically consuming these topics. Why? Because you need to be able to place them based on where they are, right?
Yeah.
So
Yeah.
it needs to understand where this is and where this information is. So as you can see, everything is decoupled. They have no idea that any of them exist as long as they know I just need to subscribe to this topic, process this topic, send it back. That's all. So
Yeah.
it's kind of like the analogy of the whole um, the, the, the the manufacturing plant belts that I was talking about. I take
Yeah.
my job, I finish my job, I put it back in the belt. I take another job, I do my job, I put it back in the belt, and it's the same way.
Yeah.
Um, this
Yeah.
way,
And
you can just go for it.
no, I was gonna say, like, I mean, just to like bring it to real world terms, like somebody who's working like assembling a car, they do not care at all that somebody ordered a car. They're at the point where like, okay, my job is put on the doors or whatever. But like
Exactly.
and it also makes sense from a security standpoint, you know, like the invoice agent just needs to know a ride was created. It doesn't necessarily need to know everything about like that ride, you know. So because like I find a lot of times, especially you know, people can give too much information and it's not necessary. One, it's just extra stuff you don't need, but also like just from a security standpoint, you know, like so.
No, yeah, fully. Yeah, that's the whole isolation is you have control over how you
Yeah,
want to do it here, right? And then let's say the orchestrator now says the agent, and here's your ride. There's a simulator. I mean, obviously, I need to like move the cars from location A to B, so I
yeah,
introduced like a simulator service. So basically, what it does is it knows where the user is, it knows where the taxi is based on the ride information. It sends that info, the coordinates to Mapbox. Mapbox is like an external service that I use, which gives me the actual coordinates of the routes
mhm,
um, that is needed in any particular city. So it's a pretty neat service. I send in the coordinates, I get back the routes. I get back the routes like a vector of like coordinates that I plotted in the um, simulator. So I say, hey, from
yeah,
move this from point A to point B, go through these coordinates. And that information is fed here. And since it's fed here and since it's consumed by the front end application here, the front end can actually move the car based on the coordinates.
yeah. No, that makes sense. Yeah, I've actually
And
heard
at
of
the,
Mapbox. I've never used it, but I have seen
yeah,
it
it's
come
pretty neat.
online.
It's pretty neat. It also gives you a lot of other, like you can reverse, like you can give a city and get the coordinates. You can also give the coordinates and get the city. You can get like
Oh,
traffic
nice.
updates, and so that it's kind of like really helpful in especially when you're showcasing such travel apps and things like that. So there's simulators doing that, and at the same time there's an invoice agent. So the moment there's a ride, this invoice agent can asynchronously start processing. It doesn't even have to wait the ride to get over
Hmm.
or the simulator to over, because you finish the simulation, because the ride, you already assigned a ride, the taxi is on its way, you got to pay because you've already booked the ride, you can't cancel it. Obviously I'm not it's not at a state where it's like a real Uber where you can cancel it or
Yeah, yeah,
reach
yeah.
it. But you get the point, right? Like this can happen asynchronously, and this agent is like, okay, here's where it's trying to bring in that intelligence part is based on the current location, it's going and figuring out. Um, so it's giving a prompt to Claude and talking and telling Claude, hey, listen, here's the city. What is like the live rates based on the hour,
Okay.
based on the city? What would be the live taxi rates for this particular distance? Give me that, and then Claude gives me that information, and then I send it to a serverless Postgres database and I process it.
Okay.
So this is kind of like the whole view of things, but I want
Hmm.
to bring like a point here. where initially, before, I didn't have observability in place here. What happened was I ran the simulation overnight, and then eventually, what happened next day, I had a hefty bill
Okay.
from, because for every single write that was requested, I was here. There was initially a call to Claude, which I removed it, and I'll tell you why. Because I was telling Claude, hey, here are the taxis. Here is the user. Figure out who's the best taxi available. Assign it. And
Okay.
so every time there was a taxi request coming in, this agent was sending it to Claude and getting it back. And then when I installed, and then I'm like, this is so stupid. I don't need to make this call to the LLM. And this is a classic case of over engineering that I did in the first
Okay.
place. It's like I absolutely did not need to have make an LLM call there, because I had all the information in there. And then that's when a tool like Langsmith is like this observability platform built by LangChain, where I installed that, and then I was like, oh wow, for every call it was taking like 2 to 3 seconds to make that decision, and I'm also using the tokens, which eventually turns into dollars,
Yeah.
and I could save that. And this is like a lesson, and also my learning is, don't over engineer when you, and then apply the Socratic principles, like ask why 5 times. At the end of 5 whys, if you still think that's the way to go, do it. Else, if you don't have an answer, then you don't need it.
Yeah.
um, and in similarly, in this case, I didn't have Redis before. And then I was like, how can I optimize this? So optimization comes later, right? Like first you need to
Yeah.
build it and then learn things the hard way, like I did. And then optimization is like, during one particular time, there is this simulation that I'm running in a city. The taxi rates are not going to change significantly, right? I could store this information at a Redis cache and then retrieve that, instead of making an LLM call for each and every single taxi request that comes in.
Yeah.
So that way, instead of, if I'm simulating 10 different rides, I could just do one call to the LLM and then store that information. I'm saving on 9 different. So these are like how observability plays a really crucial role in building such distributed systems, particularly when you're using AI, when it requires a lot of money and things like that.
Yeah, for sure. And like to your point about like you got a hefty bill, like FinOps is a real thing. Like so like if you not having that observability, like you said, you didn't realize, and then now you do, and then you're like, oh, okay, well, gotta throttle that or pull it out, and even the caching with Redis, like caching doesn't even have to be that long. Like even like in web, like when I was working at Netlify, it's like if you just do regular HTTP caching, we had CDN and stuff, but like you know you could get hammered on pages, and it's like it's cool as a cucumber, and it's the same thing here. Like you could maybe have like those rates even cached for a minute, and you get like 1,000 requests, and that versus 1,000 LLM calls is like
Calls.
pretty significant, right? So
Yeah. Which is why my app is now, I'm trying to un-AI my AI application. um,
yeah.
yeah.
No,
So, yeah, go ahead.
no, I was gonna say it's funny you said because like obviously your talk was about like AI agents with EDA, but it's a good case. Like you don't need AI for everything, and like we were talking before the live stream about like cursor and like other agentic IDEs, and like you even see in the I remember I was moving, like I have a Astro website and I'm moving my blog posts to consolidate stuff, and I said like rename these, move these, and then like the whole renaming or like fix the structure, you know obviously the LLM could literally just keep doing that, but it was smart enough to go, let me write a script that's temporary and I'll do, you know what I mean? And like even the LLM was able to say like, you don't need me for everything, like hold my beer, kind of.
Yeah. I mean, the principle remains the same. I mean, you definitely need to think about event-driven architecture if you want to process these information at scale,
Yeah.
right? The AI aspect of things is, in essence, now I have this framework now, and I think it's in a pretty decent shape. Now I can go into adding intelligence to the agent, but the communication
Mhm.
is still going to be through this framework.
Yeah.
Then I can go like, do I need an MCP server for this particular in this case, or um, what kind of context can I build with my agent? Can I become much more intelligent? And something that I want to experiment is, can each of these taxis be an agent in itself and start talking to one another, and decide on its own, even without an orchestrator agent? And let's say these taxis become smart enough, and then say, okay, you go, or but how would that work? And so as and when I'm building these kind of apps is when you kind of realize where to apply AI, where to not apply AI, and which is what I said. Like, people are, they just want to slam AI into everything. I'm like,
Yeah.
that's uh, that's not the way to do it. If you go through the process, um, eventually you'll get to a point where you need that, but you also have many cases where you don't need that.
Yeah.
So
No, for sure.
that's
It's like I'm kind of half joking, but I think it's kind of a real thing. Like, hey, I just registered an AI domain. Where's my VC funding? Kind of, but and the other thing too is like when I was working at open source before Pomerium, can't remember where I saw it, but it's like, everybody, like, I understand why you market things like AI powered this, AI powered that, or like, get your invoices through AI. But at the end of the day, it's like users probably don't care about it. They just like, I want my invoice, or like fix it. And so like you're still like, I think it's better to be more like feature driven than just saying it's like AI powered. Like, sure, it might use AI under the hood, but at the same time, I understand why people say AI powered, because like it definitely gives signal to people. So
I mean, there's always it's always nice to have the option of enabling it, right?
yeah,
That's always the case. But at the end of the day, whatever AI or non AI or whatever, you're spending dollars. What's
yeah,
the ROI for it? That's the bottom line.
yeah, totally.
It doesn't matter if your system uses AI to make that call, to make that decision or not. At the end of the day, why do I need to spend those extra cents or whatever to make that
Mhm.
decision? Is it
Yeah,
absolutely saving me time? Is it's needed? Is it much more efficient? There are so many questions at scale. But
yeah,
again, this is only each one of them can answer this question. And as in, like, you, my suggestion would be, take an idea and start building on it, right? Like, ask why, and then you will eventually get to a point with that. So
hmm
um,
yeah,
I,
yeah. No,
now,
totally.
all right. So now I'm going to open my terminal. Fun stuff here.
All right,
Um,
live coding. Nothing will go wrong.
yeah,
Do you mind just zooming it in like once or twice? I don't know if you can zoom your shell or not, but oh yeah,
is that
perfect.
fine?
Yeah, that's great. Yeah.
Right. So I've checked out my repository and stuff, but Hive is like the shell script, that Cursor did it for me. So that's, Cursor is pretty decent at like shell scripts and stuff. That makes my job so much easier. Where it
Yeah.
actually, like, in this case, what it's going to do is, whatever you saw, all those services um, are containerized. So it's going to go and like, maybe just do a Docker Compose. And so you see, basically, I have an entire Docker Compose file with all these services and configurations in place. It's basically going to spin it up in a certain sequence, because you need the brokers coming up first, and then you need to have all these services,
Okay.
database connections, and everything. So once everything is up, we can see. So
Okay. And quick
so
question: is this all open source in your repo somewhere,
now
or
it's
is it
closed source.
okay,
No,
okay. It's
so
all good. It's all good.
you gotta attend my talk for it.
Okay, gotcha.
So Hive is something, yeah, shortcut, and then I'm gonna say Amsterdam, right? So in Amsterdam location, we want, let's say, 50 users, and then I want 5 taxis. So there are going to be
Okay,
5 taxis. There are going to be 50 users that are popping up every 10 seconds, and then our taxis are going to, go.
okay,
I've now extended it to like a couple of cities, but if this goes well, we'll try and do it for a couple of other cities as well. So I'm going to run the. Oh, brilliant. Oh, I missed a. like
Oh yeah.
right, okay. So it says that yeah, it's starting 50 users. So it's basically setting up all the containers.
Okay.
um so I think as and when it's coming, I'll probably also show I have Docker desktop here, so you see
Okay.
all the services are coming up slowly.
Cool.
um
You mind zoom? Oh, if you go back to the
yeah,
browser later, just zoom it in.
yeah. So it's now
Uh,
creating the right topic, the taxi topic.
okay.
The user topic is created. So there's the broker, the central system is set up. Now we're starting the core services, which is basically the orchestrator agent needs to come up. Um, so which is the right orchestrator agent here.
Okay. And so I guess in the Docker Compose, you kind of have health checks to say this thing is live. So
Yeah,
does
so it's
that
like
depends
basically, yeah,
on?
there's like some, that's why the delay, though, there's health checks to make sure like all the services are because this is such a complex system. It might look like whatever, but there are like, I think 10 different services talking to one another.
Mhm.
And when you're doing a live demo, you really need to make sure that, uh, so yeah, so things are up hopefully. And then if I move to my browser, you see now,
Okay. Yeah.
you see the
Stuff's happening in Amsterdam.
stuff's happening. This is not a recorded demo, folks. It's actually you see a live counter here,
Yeah.
and it's
There's not 4 people with mice moving it around.
so these are actual routes. It's not like just jumping somewhere, but obviously, yeah. So if I zoom out a bit, then you can also see it. But while we are doing that, we can also like go back to the. So you see, this is the orchestrator agent that like constantly I get like taxi updates, and the agent is now assigned this turn Van Brennan to with Elizabeth, who's requested it.
Okay.
Um, at the same time, if I do the billing agent location, so you see for ski pole, I've already so there's a fair location calculation happening, how much base fee was there, what was the R, what was the total fee, what was the total cost, and these invoices are also getting generated.
Okay.
Everything is happening asynchronously, so it's not like it's waiting for something to happen. And if I look at, so these are like the uh, basically the users generator that you saw there. It's basically randomly placing a particular user in Amsterdam with a particular name and etc. Um, yeah, and then that's what you see here. And then while this is happening, you can also go to the Postgres, right? And let's refresh it a bit to make sure all this information is there.
You mind zooming in just a little bit
Yeah,
there?
yeah,
Cool. So this is just to be clear, this is obviously real time updating.
yeah.
Yeah.
Real time. So
Yeah.
this is real time on the 16th
Yeah.
today. Like you see the distance travel, the price, everything. So all that billing agent is now, after it's built and everything, it's sent me the whole data here, which I can later use to process whatever I want to, right? And then it
Yeah.
also gives me like a daily stats update on, if I do this, so 16, there are a total of 31 rides, total revenue made, what was the price per kilometer, all this information is up there. So what was the
Okay.
P card was at 1 o'clock because you're like almost right GMT now. So this information is happening, and also at the same time, you go to Langsmith where the observability is there. You can also check what kind of prompts am I sending, what was the LLM pricing, where did it visit, what was the base fee, how did it calculate, and all this information.
Okay.
So this is the observability in place. Later, I obviously want to get into security best practices and have that, and then maybe have some MCP integration, which I'm definitely lean into you for it. But yeah, so it's still running. It'll still complete all the 50 rides. We're done with 38 now. Yeah, so that was the live demo of everything that's happening right now.
Yeah. No, that's super cool, and like I'm sure it sounds like you had a lot of fun building this, and like it's it's a good example of an event-driven architecture. Like you obviously you have more of an infra background than me. I've typically been mainly an application developer, so but I definitely like how you broke it down and like met messaging is key in this, whatever you're using. I mean, Kafka is obviously a very popular one. I know, like, there's like, I don't know if RabbitMQ is considered equivalent to Kafka, but it's messaging as well. But
We could use RabbitMQ for sure. I mean, it's definitely there, but Kafka has obviously its advantages. And I also deliberately wanted to learn more about Kafka, and I did that
okay,
intentionally as well.
that's cool.
But yeah, so it's that's yeah. I also have a dark mode.
Okay, yeah.
But I mean, so the idea is, again, if I when I go back to the whole thing, the idea is to learn. That's the fundamental thing, but also like showcase what is possible, and trying to yeah, update it, and then just
Yeah,
inspire people on what is possible. And it's just a journey for me. It's like I'm learning a lot, and then my is going to be like, how do I incorporate MCP servers? Do I really need it? How can I make these agents much more intelligent?
yeah,
um, is there some machine learning that actually, okay, during peak hours, this is where we see much traffic, but for all that information, I have the data, right? Like now I can feed that data, and like I can go in any direction, but then um, I need to be very like a lot more structured about how I want to approach continuing to build this project.
yeah. Yeah, no, and yeah, like you said, you're mentioning MCP, and like looking at your diagram here, like the taxi generator, ride simulator, and user generator, those look like tools to me already. And
Mm-hmm.
like, so like maybe it's not necessarily putting MCP servers in your architecture, but maybe exposing this as an MCP server. So because like for example, right now you started the CLI, you said I want 5 taxis, I want this. You could probably, uh, whatever your MCP client is, whether that's like Claude or like Goose or whatever people are using, even VS Code, you could say like, you have your MCP server installed, and you could say like, I want to, like, you could write in plain English, I want to generate a simulation with 5 taxis, for Amsterdam, and I forget what the other
Yeah, there
parameters
was
I think
like
there was.
Berlin. Yeah.
Yeah,
Mm-hmm.
and then essentially your tool calls in the MCP server would have a definition of what like they can do, and
Mm-hmm.
ideally, if it's described well, the MC, like it should be able to figure out like, okay, Abby's asking to simulate 5 taxis in Amsterdam, with
Yeah, yeah, maybe like I can have like a chat interface where I can just like keep asking this, because right now then I need to like go to the CLI and like maybe add more parameters, because like the simulation is over now. What if I want to extend it? I just need to now
yeah,
right now either go manually and just run that script, or I need to take it down and bring it back up and do it. So maybe I can just have like an interface where I can just say run now, because the services are up and running anyway. All I
yeah,
need is like, I think that's a very good point. Like, thank you. I could probably do that.
yeah, and well, one, I think it'd be fun to do, but and then you can like obviously, from a security point, like obviously, like I work at a security company, like it makes sense to put something like Pabarium in front of this for authorization and also just policies and stuff and all that jazz. But like, because like for example, like obviously this is just a demo right now. I mean, a very good demo, but like, you don't want necessarily anybody just running your MCP server, so like that's where like policies and making sure people are logged in, like, it's kind of seems almost like table stakes to me, but like literally the way you wrote out those things, they scream tool calls to me in the MCP server right away. And you were asking, we were talking briefly before the live stream, and you're saying like, maybe I can make Mapbox and MCP server, and like I think within the architecture you have right now, it probably doesn't make sense to
Exactly.
shoehorn it in
Yeah.
there, like, because if you did that, the ride simulator would have to be an MCP client
Client. Yeah.
just
Yeah.
go to there, and at the end of the day, you're really just making an API call. So like,
Yeah. Which is why I didn't want to do it. Yeah. Because you can just make that API call and it's still there for me. I can
yeah,
still make it. And I'm also like, caching the routes anyway, so I don't have to make a lot of calls.
Yeah, and the thing is, like in that particular case for the ride simulator going to Mapbox, you literally know what you want. It's deterministic, like
Exactly.
not the different data, but you're always going to the same
Yeah.
endpoints. So, like
I
the
think you
thing,
brought up a very important word, and that's something that I also wanted to emphasize is use these AI agents for undeterministic thing. For deterministic thing, you
yeah,
don't need it because
yeah,
that's
or
very important.
yeah,
Anything that's dynamic that requires like let's say there's going to be a accident or there's a traffic update and I need to make a reroute of things, it's not deterministic. And in that case, if I'm applying trying to apply it for this particular example, that's when you need something like that.
yeah, no, for sure, and this is also where like an MCP server can shine too. Is like there's a lot of MCP servers right now that literally just translate APIs to run as an MCP server, which works. But like I think the thing with uh, agentic stuff is like we're all devs, so like devs might be like, okay, yeah, I'm just gonna call the API, whatever. But like think about like your parents or somebody not in tech who's just gonna be like, I want to book my flight. Like they don't know, they don't care that there's some API to go to airline to
Yeah.
find blah blah blah. They're just gonna say like I was hanging with Tejas Kumar a few weeks ago on the live stream. He, excuse me, I'm dying.
Yes, yes.
And it's like it's just more like he was like, I want an agent or like I want to have an agentic experience where I can just say like, I don't care what you do. I need a flight to Amsterdam and I have to be there sometime before noon. And like, and here's my budget. And, and that's not something you can do with an API call, right?
No,
Like
yeah.
kind of one to one, you know what I mean? So
No, no.
this is where like the agentic experience comes in and it goes, okay, I'm trying to look for some flights. Okay, I've got flights for the time. Oh, let me, and that's when it starts to do like figuring things out. And I think that's where that kind of experience shines more because like
Exactly. And so that is like a human experience, like the human interface. So you don't
exactly,
like the AI does not know what you're going to ask for.
yeah,
In this case, the we kind of know what we are expecting. Like we know, which is why your example of applying it to the simulator makes much more sense because the simulator or the client does not know what I'm going to ask.
yeah, exactly, and like
Because
and there's a
otherwise it's very deterministic. I exactly know where the locations are, what it's going to be. But
yeah,
ultimately
exactly,
my point is again, it's about like how these asynchronous event driven architectures paradigm like can help with these kind of like multi-agent systems at scale. That's the
oh yeah, for sure, and like a lot of agentic workloads are, you know, it's not just MCP servers and an LLM. There's like a lot of these, cloud based or frontier like there's Kubernetes running behind all. It's not just like it's not just like let me start up a script and here we go.
yeah.
There's a lot under the hood and like there's stuff I'm still learning because like I don't come from an infra or like I'm not a platform engineer. So I it's kind of I've just been having a lot of fun learning stuff.
No, I
And
mean everybody. That's what I said. Like embrace the agentic AI from your perspective, from your expertise,
yeah,
right? Like I still need to explore your platform and how you could. So, I mean, I know we're. Oh, I have a hard stop in like 5 minutes, but
yeah,
if you can
yeah.
quickly tell me a bit more about like Mariam and how you're applying like security practices to it, and maybe after the call or maybe for future stream or a discussion, I would love to incorporate Mariam into the mix and see how that's actually helping me.
Yeah, for sure. Yeah, no, and yeah, happy to do another live stream. So in a nutshell, it's always I continue to work on the elevator pitch for this, but Pomerium is based off of zero trust security, and at the end of the day, what that means is it's an identity aware proxy. the TLDR, I have some talks I can share later, but like it's based off of technology that came out of Google after they had a massive breach in the 2010s. They literally rethought security from the ground up. And so there's these papers called the Beyond Corp papers. If you just Google that or ChatGPT, you'll get information about it. But essentially, yeah. And so essentially, you have what's called an identity-aware proxy, and that's what Pomerium is. And so there's like three major components to it. You have like an identity provider, and that it works with any identity provider that's OIDC Connect compliant. So that's for in layman's terms, that's where you log in. So whether that's Google, GitHub, whatever you're using for your IDP. It could be Keycloak if like a lot of devs like that.
Yeah, Keycloak.
So you log in. That's one thing. So like if you were going to access a particular service, it's proxied. So there's the logging in part. There's the proxy. So the actual services are never exposed to the public internet. And the other thing is you have a policy engine, and that determines like, okay, Nick logged in or Abby logged in, but he's not in this group. That's like a very basic thing, or his email domain isn't right. Okay, they can't access a certain thing. So the typical flow is like, I want to go to secureroute.digitalocean.com, and it's some, I don't know, super internal service that only your team can access. So you're going to go to that URL. That's a public route on the internet. And you're going to try and hit that. And what's going to happen first is it's going to say, okay, you're not logged in. Let me redirect you to the IDP. So the identity provider, you do the login flow. It comes back to the identity aware proxy and it goes, okay, Nick's logged in. Let's continue. Okay, let's check the policies for this particular route. And in this case, a route in an identity aware proxy is not like, for people who've done a lot of front end or just app development, it's not like /API something. It's a literal URL, like the main URL. And then you obviously have other folders in there. But so it goes, okay, Nick has a DigitalOcean.com domain for his email. So let's let him in. Okay, perfect. And then I get routed to the internal service. And an important aspect of this, and I know we're almost at time here, but like there's micro segmentation. So basically I'm never exposed to your entire internal network. Whereas if you're on a VPN and you get access to it, you literally have access to everything, potentially do malicious stuff. This is like, if something goes wrong in this particular service, it's not affecting the other things. So there's that from a security standpoint. Also, you're going through the proxy.
I think even with like agents, you can apply this. I think it's pretty powerful because you want to have the isolation in place. Particularly when they have
and that's literally what we're doing with MCP. Like we're an identity aware proxy to begin with. We're not an AI company, but because we run at layer 7 the proxy, it fits really well with MCP servers because it's the application layer like HTTP. And I'll drop a link to our docs about it for people that are interested. But in essence, this fits really well with agentic workflows because you're always going through the proxy. You get that observability, so you know who came in, you know what the payload was. So like, and even like prompt injection is a big thing right now, and I know you gotta hop off, but like that's something you can catch at the proxy level. And even coming back from the proxy, once you get your response, you can actually sanitize things because like maybe you asked for something and it gave some personal information. You might not want to send that back because like that's not really what you cared about. It was more something else. Like if you think about like health patient data, like we just want to know this cancer patient has stage 4 and these are the things. I don't need to know that it's Nick Taylor. You know what I mean?
Yeah, for sure. Like medical things is, I worked at a medical startup. Getting FDA approval is insane.
So that's kind of it in a nutshell. But yeah, happy to chat about it again another time, and we can definitely sync up even offline and just talk about some stuff.
Sure.
But
for sure.
I'm obviously biased because I work there, but honestly, I think it's pretty cool shit that we're working on right now. So
that's nice.
but yeah, I know you got a hard stop, Abby. So I just want to say thanks for taking the time to hang today. I know you got a lot going on. You're heading to a meetup. I'll just drop a link where people can follow you on your website, and there's also your LinkedIn. Thanks so much, everybody.
Thank
Thanks
you.
for tuning in, and yeah.
Yeah, thank you, everybody. Thanks, Nick, for having me.